Welcome back. What do you call a man that can't stand? Neil. All right, so let's take a look at what we're doing today. We are continuing on with differentiation, and we're going to see what happens when we start introducing negative indices. Long story short, TLDR, business as usual. We differentiate using the same rule as usual. Just a recap of negative indices real quick. If I have anything to a negative indice, it gives me the reciprocal, and then the power becomes positive at the bottom. Okay, so a to the negative m is the same thing as 1 over a to the power of positive m. That's going to be helpful when we start to try to differentiate these next couple terms. Okay, for the first one here, when I say business as usual, it means the same rule applies. So first things first, the power comes down to the front. And then what happens is we take away 1 from the power. And that is it. Done. As usual. Okay, now for something like this, where I have x to the power of 5 on the bottom, I need to recognize that this can be written as a negative indice. So I can write it as, I haven't differentiated yet, I've just written it as fx equals 3 times x to the negative 5. That's the same thing. And then what happens now is now I can differentiate it as usual. Minus 5 comes down to the front, minus 5 times 3 is negative 15. X stays the same, and I take away 1 from the power, so it becomes to the negative 6. Let's continue on. If we have something that's a little bit more, I guess, kind of intense, just notice how I play around with the numbers. In this case, it's exactly the same thing as 16x to the power of. Hopefully you picked up it was negative 3, and then I still have plus. And then this one here, whenever you've got a fraction, I'll take the coefficient out the front. And so in other words, I've just the numbers are going to stay as is, but I'm going to change the x as a regular kind of indice, not on a fraction, so I can differentiate it easier. So in this case here, now I'm going to differentiate. Minus 3 times 16 is minus 48. X, take away 1 from the power, becomes negative 4. And then this one here, if you want, you can write plus, and then it becomes negative 6 on 5 because the power comes down to the front. 2 times 3 on 5 is 6 on 5. It'll be a negative as well, x to the minus 3. So cleaning that up a little bit. And usually what happens is you want to write your answer in the same form as your question. So here I've got minus 48 over x to the power of 4. And then I have this plus minus thing going on here. So I recognize it's going to be a minus 6, and then the 5 goes on the bottom, but so does the x to the power of 3. That would be our derivative. Okay, hopefully your arithmetic is good to keep up. And do I have one more? I do. This one's a little bit of a special case. What happens if I have a fraction where it's kind of, there's 2 terms on top and 1 term on the bottom? This is where separable or separatable, I don't know which is the correct term. But here I've definitely got something that would be difficult to differentiate, especially because I can't just, this applies to both terms. So let me explain what I mean. I'm going to take a couple goes here to try and fix this. This will be x squared on x to the power of 3 plus 3x over x to the power of 3. Can you see how I've separated it into 2 terms, keeping my denominator the same? Now, if I was to calculate this would be, or simplify, this would be 1 on x. And this one would become plus 3 on x squared, just by canceling out the x's, the common factors of x. And so taking it a little bit further, this becomes x to the minus 1. This becomes plus 3x to the minus 2. And so now differentiating should be a little bit easier. So power comes down to the front. Take away 1 from the power. Same thing here, minus 2 times 3 is minus 6, x to the minus 3. And again, leaving my answer similar to my original form, this would be negative 1 on x squared. And this would be minus 6 on x to the power of 3. Okay, hopefully that makes sense. I'll catch you in the next video. See you later. Bye-bye.